Professor Bumbleweed here. People treat cloud computing like a mysterious place where files go. It is simply computing done on remote servers you access through the internet. This quick explainer shows what runs where, how services stack, and why your device stays suspiciously calm about it. This explainer stays informative and mildly entertaining because pure boredom counts as a security risk. Cloud computing equals remote servers delivering storage, computing power, and applications through the internet. Time to look closer at the invisible trip your data takes and why it returns so fast. Cloud computing means your device stops doing all the heavy lifting. It sends requests over the internet to remote servers and data centers, then receives results back. So yes, your photos and documents live somewhere else, inside real buildings full of computers, power, and cooling. In the cloud, one provider runs massive pools of hardware. Software slices that hardware into shareable pieces. So many customers use the same physical servers without touching each other's data. Think of it as apartments inside one sturdy building with serious locks and strict rules. Software as a service means the provider runs the entire application stack, and you access it through the internet. Your device shows the interface, while servers handle storage, updates, and scaling. It is wonderfully convenient right up until you forget your password at the worst moment. Other cloud layers give you more control. Platform services handle the runtime and deployment tools so you focus on your code. Infrastructure services rent virtual machines, storage, and networking so you configure more yourself. Either way, you rent capacity from a provider instead of buying hardware. A big cloud advantage is elasticity. Capacity scales up when demand spikes and scales down when demand drops. That beats buying enough servers for your busiest day of the year, then staring at idle hardware the rest of the time like a very expensive decoration. Cloud services often stay accessible from many places because data lives on provider servers, not one device. Providers also design redundancy, like storing copies in multiple systems or locations. It is not invincible, but it beats the classic plan of hope this laptop never dies. Cloud security is a teamwork situation. Providers handle physical security and core infrastructure hardening. Customers handle identity, access rules, and how data gets stored and shared. Encryption and monitoring help, but none of it fixes careless permissions. The cloud is powerful, not psychic. Cloud has trade-offs. If the network connection is slow or down, remote services feel slow or unavailable. Providers also have outages sometimes. Costs can also jump if usage grows without limits. Renting resources is great until you rent too much and learn math the hard way. When you open a cloud service, a request travels through the internet to a data center. A load balancer routes it to an available server. That server reads or writes data in storage, then sends a response back. The speed comes from automation and lots of hardware working together quietly. Cloud computing has choices. Some teams use public cloud services, some run private cloud, and many blend them in hybrid setups. Service layers also vary, from full applications to raw infrastructure. Pick what fits the job, your security rules, and your budget. Yes, budgets matter. Sorry. You just watched cloud computing in plain reality. Devices send requests through the internet, servers and data centers respond, and software layers decide how much you manage. You also saw scaling, redundancy, and the not-so-fun bits like outages and cost control. The static TV picture captures the whole flow without the mystery branding. If the cloud finally looks like real servers instead of a cartoon sky, press like so that feedback reaches the humans behind the channel. Share topic ideas in the comments too. Without prompts, I keep standing here silently while the animators panic. Nobody wants that. Until next time.